Hey guys, today we're going to be talking about scatter plots. And scatter plots, as you can see right here, are a graph that has a ton of different things on it. Okay, if you look at them, they don't make a straight line. We've been dealing with straight lines all chapter, but right now a scatter plot isn't going to have a straight line. We are going to put a straight line on it though eventually. So when representing data from a table on a scatter plot, match the data values to the coordinates on the point. So if they give you a table, what you're going to be doing is figuring out the table goes with which graph, okay? So what that means is if we look right here, Sabrina's planning a surprise birthday party for her sister. She collected information for the costs from different venues and different numbers of guests at the party. The table below shows the information she collected. So we have the number of guests, which is our X value. Our X value is always on the top on a table. And we have our Y value, which is the cost of the party. And if you look, they labeled those on the graph for you. And then which scatter plot represents the data. So on a problem like this, what you would need to do is just find out which table matches the graph, okay? So what that means is go to number of guests 4, I should have $65. So 4, that's about 60 some dollars right there, okay? Then I'm gonna go to 14, so that's gonna be right here, and it should cost me $170. So I'm gonna go up here, and if we look at 14, it should be at 170. Well, it's below 160, so we know W is not our answer. So I'm just going to cross that one out real quick, okay? So I know it is not W. And I'm just using process of elimination to figure these out. So then you do the same thing. 4 should be at 65. That's about 65. 14 should be at 170. That's about 170. Okay? 6 should be at 92. That's about 92. 21 should be at 230. 21 should be at 230. Okay, if we look here, 21 is not really at 230. It's actually exactly on 200. So we know it's not that one either. So then we're going to look at these again. Okay, 21 should be at 230. So if we go over here, 20, that's about 230. Okay, if you notice, it's going up 20 every time. So if you look at this graph, 60, 180, 120. So if I look here and go 21, that's below 220. And we want it to be at 230. So it is not Y. So that means the only graph that is going to work on a problem like this is Z. So that is how you do a problem like that on today's assignment. Okay. Another problem we're going to talk about is lines of best fit, and that's where we're going to put a line on our table or on our graph that we would suspect would be the best fit. Okay, so line of best fit. Some scatter plots display points which appear in a trend toward a linear relationship. They do not form a straight line. What that means is if it has a trend, if you look at a scatter plot, I'm just going to draw an example here, and they put a bunch of dots on it. Those are really big dots. We're going to make those a little smaller. Okay, they have a bunch of dots on it like this. Okay, what the trend means is if I have all these different graphs, right? So a form of a positive correlation, if you look at my graph right here, the overall trend of my graph is those dots are going upwards. That is known as a positive correlation. Okay, positive is going upwards. If you look at this graph that I made, the dots are going downwards. That is an example of a negative correlation. So we're going to be making lines of best fit. So some scatter plots, data points, which appear to trend on a linear relationship but do not form a straight line. A linear relationship can be appropriate relative to the data by using a line of best fit. Pretty much what that means is we can determine the data based off a line of best fit. A line of best fit represents all the data. A line of best fit can be used to analyze the data in several ways, including investigating a correlation between variables and making predictions outside the displayed data. So on a problem like this, they want you to say which of the scatter plots below shows the most accurate line of best fit. Okay, so if I have 4 graphs right here, and they all have the same dots on them, what a line of best fit does is a line of best fit is going to go through about the middle of all the data. So what that means is if I have a graph like this, and my dots are going like this, a line of best fit is going to go through the middle of everything. It's not going to touch every line. It might, or every dot. It might touch a couple dots. It might not touch any dots, which is okay. We want it to go through the middle of all of our data. So an example of a bad line of best fit would be if I had that same looking graph, okay, And if I made a line of best fit like this, that would not be a line of best fit. That would not be a good one because this line right here does not go through the middle of all my data. Okay. Same thing if I did like this. It goes through some of it, but if you look right here, it doesn't go through all of it. We want a line that goes through the middle. And like I said, it doesn't have to touch everything. It doesn't have to touch every dot. It just has to touch through the middle. So if I was going to make a line of best fit for that graph that I made in the middle, it would look like that. So if we're looking at these other problems right here, W, X, Y, and Z, they want to know which one has the best line of best fit. So if I look at W, I would say W does not have a good line of best fit because if you look through it, most of the data is below it. We want the data to be equal on both sides if it's not going to go through the middle. So like right here, only one dot's above it, but there's a ton of dots below it. So that would not be a good example of a line of best fit. Okay, we look at X. This line goes through, but at the same reason we canceled this one out, it doesn't really go through the middle. We want it to go through the middle. Okay, so it can't be that one. Same thing here. It's not equal. We don't have about the same on each side, so it's not going to be that one. So if we're looking for a line of best fit, if we look at Z, we got 1, 2, 3, 4, 5, 6 dots below it. 1, 2, 3, 4, 5, 6 dots above it. Yes, it does not touch any of the dots, which I just said was fine. Okay, we want it to go through the middle of our data. So I would say Z would be the best option for which one is the best line of best fit. Moving on. So a scatter plot, like we talked about, scatter plots are used to examine two sets of data and investigate the relationship between a trend line or a line of best fit. Also helps predict that. So right here, the scatter plot below shows the number of days it's taken to development the team to complete their last 15 projects. So this is the project number. This is how many days it took them. So what they want us to do is they want us to draw a line of best fit in here. Use the information in the graph to predict how long it would take them to complete 20 projects. So I'm first off got to draw a line of best fit through this graph. Okay? So I'm going to do that by just taking a line, a straight line tool, and I'm going to draw it. So if we look at this one, probably won't be a good line of best fit because it's not really touching all the data. Okay, same thing here. If I did this, not a good line of best fit because it's not really going through the middle of the data. We want it to go through the middle and be equal on both sides. So if we look at a line like this, okay, this line, we have 1, 2, 3, 4, 5, 6 dots above it. 1, 2, 3, 4, 5, 6, 7 dots below it. So it's about in the middle. And now what they want us to do after we have drawn in a line of best fit, they want us to figure out if we were to predict how many days it would take them to complete a 20-day project, okay? Or project 20, I should say. So if we're looking at our line of best fit right here that we just drew in, if we go over to 20 days, okay, so project number 20, which is right here, and I go straight up until I hit my line of best fit. I made a triangle, which is fine. And then I'm going to go straight over to figure out how many days that I should predict that take. I'm predicting that would take about 20 days. And we can do that with any number now. Even if they ask me, okay, predict if they did 17 days, or 17 projects, how many days would it take to complete? Well, if we go to project 17 and we go up to our line and then we go over, they'd predict it'd take about 17 days. Okay, so that is how you read a line of best fit and use it to predict the future. Okay, we're going to use it to predict what's going to happen eventually. And the last thing we're going to talk about is writing an equation for a line of best fit. So what they want you to do is the graph below shows a line of best fit for the data collected on the cost of a miniature golf in relation of the number of players. Okay, so the number of players and the cost. So if you have 3 people, it's going to be about that much. So when we have a problem like this, they want us to write an equation, write the equation of the line of best fit. There's a couple things we need to do. First, we need to find the slope. After we find the slope, we got to pick a point on the line. And then we're going to plug it into y minus y1 equals m times x minus x1. Okay, so they made the line for us. So what we need to do is pick two very easy points that we can work with. And it can be any point on this line. So what I look for when I'm doing a problem like this is where it crosses perfectly. So see right here how it crosses perfectly right with that, kind of like at that little intersection right here and right here. Okay, I'm going to pick that point as one of them. So that point is going to be 0, 4. So I'm just going to put that right here, 0, 4. Okay, and then I got to pick another one where it crosses perfectly right here, which that point is 2.5 and 10. So the first thing I have to do is I have to find the slope. And if you remember, our slope formula is y minus y1, or sorry, y2 minus y1 over x2 minus x1. So I'm going to go my y2 minus my y1. So 10 minus 4 over 2.5 minus 0. 10 minus 4 is 6. 2.5 minus 0 is 2.5. Now, I know we've always talked about leaving our slope as a fraction. Today is the only day I'm going to say use a decimal. So 6 divided by 2.5 is going to give me 2.4. That is my slope. So that's step 1. Step 2, pick a point on the line. Use the easiest point you picked. Okay, I'm going to use 0, 4. And then we plug it into this formula. So y minus 4 equals 2.4 times x minus 0. We distribute, like we've been doing, y minus 4 equals 2.4x plus 0. And then we add 4 to both sides. So y equals 2.4x plus 4. And there is my answer. And that is how we find the equation of a line of best fit. Okay, so hopefully that's making sense. Hopefully you're understanding. Thanks for watching, guys.